So here, what does this represent? Don't work it out. What does it represent? Yeah, it's the area under x squared minus x from x equal 1 to x equal 4. I put under in quotes because when we say under, we don't mean whoa, then everything would be infinite. When we say under, we actually understand that the ground is the x-axis. I love it. So another way to say this, a better way to say this, even though I'm not going to say it all the time because it's quicker to say under, is the area between the x-axis and the function. I like it. And if the function dips below the x-axis, the area actually becomes negative. There's some teachers make a big deal out of, and it's really not. Right? Part of section 5.4 talks about like if f of x is an amount of something, what's f prime of x? It could be like a rate of change of that thing. So if f of x is the amount of water in a tank, f prime of x is the rate of change of that water. So in that case, it would be a flow rate. You guys with me? Okay, so we all know that the derivative is a rate. So if I do this, if that is, let's say that this amount of water in a tank, and this is the tanks, I like it, and the rate of change of the water in the tank. What does this represent? And we'll say that x is time. Yes. What do you get when you integrate a derivative? This would be what? This is according to f talk 1 and 2, in a way. This would be f of 2 minus f of 1. Is that cool? That's the fundamental theorem of calculus, part 2. Not as good as the history of the world part 1, but still. So what would this represent? It would represent the change in the amount of water, or how much water there is that you've lost if it's flowing out from 1 to 2 seconds or minutes, whatever this is. So one part of 5.4 is just giving you physical situations. So what if this was a amount of money at a certain time? This would be the flow rate, and you would hope that this would be positive because that would mean flowing in. Negative, you consider flowing out. So when I integrate, it actually tells me how much money I've got from a period of whatever years, for example. All right, maybe. So if you ever have to take differential equations, and I've talked about it a couple times, that's all about relationships between flow rates, relationships between derivatives. You actually it makes sense. The name of it is differential equations. So it could be like that would be a differential equation. You can have higher level, you can have second degree, a second order, where you have a second derivative and a first derivative and so forth. But it normally in the real world, we can observe differences easily. We can set up relationships between differences. But then I want to know how much actual heat did come in here, or how much water did we lose, or whatever. I want to know an amount. So I've got to use the flow rates and integration to get the amount. That happens all the time. In physics and, well, in the freaking real world, period. Okay. So this is an area. What is this? does that represent?
The antiderivative?
Yeah, good. All right, antiderivative. I love it. Which we can interpret as an area function. I can throw a couple values in and see the area between two things. I can basically use this to get this. And that's why the first step to solve this is to figure out the antiderivative. So go ahead and try to figure this out. Solve this sucker right here. I much prefer fractional answers. There's a lot of unique practice. Not just because of that, because it's an exact answer. What is the antiderivative of this? That's that beautiful, beautiful. I feel like some weird methodal hunter. It's beauty. It's beauty. X to the n plus 1 divided by n plus 1 plus c. Now, why don't I have to put the plus c? Why exactly do I not need a plus c here? Okay, I have inputs, but what, so what? What am I going to do with those inputs now? Plug them in and take the difference. So the constant would be the same. The function doesn't change. That's the function. So whatever c is, it would be, when I plug 4 in, it'd be plus c. When I plug 1 in, and so of course they cancel. So when I have a definite integral, I do not need, it's not that I don't need the c, there it is. It's not that I don't need it, it's just that it cancels. So it doesn't show up. So I got 1/3 4 cubed minus 1/2 4 squared minus 1/3 plus 1/2. Is that cool? I plug a 1 in, minus, so it changes the signs. So I get 4 cubed, 64 thirds minus 16 divided by 2, 8, minus 1/3 plus 2, so I get 63 thirds, which is that cool? 63 thirds, which is 21 minus 6, which is 15. That's neat. I don't know. I didn't know what to expect, to be honest. It's kind of cool it came out to a whole number. Okay, okay. Is that hard? No, that's freaking awesome. Let it be awesome. The more you understand derivatives, the easier this is. Because you're just kind of thinking backwards. Where would this have come from? So yeah, let's just talk about a few antiderivatives directly. What would this be? Secant x, I like it. Cool. Cool. Normally in a quiz or a test, if you forget plus c once, it won't take anything off. If you forget it several times, I'll take a point off for every like cluster or something. All right, what about this? What you got, Jeff? What's the biggest mistake somebody would make here that you're not going to make? It is no. There's for integration, none of the derivative rules are there. Integration has answers to those rules. U sub is like its answer to chain rule. It doesn't have product rule. It doesn't have quotient rule. Poor little thing. There's an answer to product rule that you learned. One of the first things you learned in Calc 2, if you took Calc 2. What can somebody tell me what the mistake would be that somebody makes? Somebody guys is, I'll just tell them what I think the answer is because I'm pretty sure I'll make a mistake. Natural law. Natural law got nothing to do with this at all. What's the only power that natural law has to deal with? What power would this be so that this is true? Negative 1. And that's not a negative 1 power. That's a negative 2 power. Right? So if I write it as a power, the rule is easy to see. What happens? What's the rule here? You make the power go up 1. And then you divide by it. So you see how that's the exact, see how that's the exact opposite of what you do derivatives. With derivatives, you multiply by what the power is, and then you subtract 1 from the power. Integration does the exact opposite. It adds 1 first, and then it divides by the new power. Everything's the opposite. That's how inverse functions work. Okay. So what do you think about this here? Right off of this here. I want you to really start to see. This is an issue that every student has with math. These two problems are not different. I really wish you could see that. If U is 7, that's something. If U is 10, it's the same damn thing. They're just offset. So the work with it shouldn't change at all. So it's going to be the same shit. It's going to be negative thing to the negative 1 plus C. Why does it work so easy? Because the inside is just the inside is linear. So remember, look, come on. When do I have to worry about the inside function? So if I take the derivative of this, is there going to be a chain rule piece that I got to worry about? Why not? The inside is just linear. Right? In fact, it's not even that. It's got a slope of 1. Right? No matter what x is, the slope is 1. It's linear with a slope of 1. So no chain rule is going to show up. Because what is the derivative of x minus 1? 1. So it's not going to show up. It's not that the rule doesn't apply. It's just that it doesn't change anything, so it doesn't show up. So look at this shit. Isn't that the same idea? Integration is the opposite of derivatives. So they should be connected somehow. If I integrate this, I will go to that. I don't have to worry about any U sub or anything. Maybe. So what's this? Now what comes into play? Natural law. Good. All right. So what's the... Yeah, I don't want to do that to you. What's this? So when do you have to worry about U sub? The minute that the inside is not linear with a slope of 1. I argue that you should not have to use U sub if the inside is linear, period. So for example, jeez, for example, come on, dude. Why that's like that? Oh, let's see. This one you gotta be a little careful with. So you guys, what's the integral sign? Now, I really want you to understand this. The inside is simple, meaning it's linear. You could use U sub. In fact, I'll do this again with U sub just to show you. You could use U sub here if you wanted to. It's just not necessary. But the integral of sine is going to be what again? Negative cosine of this. Now, what's wrong with just stopping there? Because if you took the derivative, what would come popping out? And is there a 2 there? No. So what must have been here so that a 2 wouldn't be there? Yeah. Let's look what that looks like with U sub. We do the same problem again. What would I let U equal? Yeah, the inside piece. What's the derivative of that? Du is 2 dx. Good, good. That's important. Do I see a 2 dx inside? I see a dx inside, right? How do I make a 2 show up? If I want to put a 2 here, I can't just do that. I have to balance it by putting a what where? Yeah. I really want that to make sense. That's a constant. It can go in and out as much as it wants to, because this is only worried about, remember the integral is? It's the limit of n's, sum of i's. Constants ain't got nothing to do with any of that shit. But x values, they can't go in and out. So what's this look like now after the substitution? What's 2 dx? 2 dx is du. And this is sine of? No. Sine of u. It's everything u. It's everything related to u. Not everything's about you, but it is everything about you in this problem. Yes, I love it. There's no x shit left over. Therefore, I can continue. If there was an x anywhere in here, you don't have a clue how to do that shit. That's calculus 3. That's multivariable shit. You don't want to deal with that yet. So this will be 1/2 what? It's the integral sign. Negative cosine of u, but what was u? So u substitution shows up in mathematics in a few different places. You can use it in the middle. It's a middleman. It makes the form of what you're dealing with easier to see. But your answer better not have that shit in there, because the question didn't have that shit in there. It's something you brought in. So maybe, possibly. All right. Now, how does? No, here. Let's do a definite integral, and then we'll see how u sub messes with definite integrals. What's definite integral mean? It's got limits. It's got numbers on the top and bottom. A line. All right, let's start over. Let's do Roman numerals now. Now, when you see an exponential, normally you're going to be like, oh my God, especially when the power is simple. What is the integral of e to the 2x? Yeah, it can't be just this, because a 2 would be there. You better put a 1/2 to kill that 2. Now, if you did u sub, u equals 2x, du equals 2 dx, you'd have to put a 2 there, which means a 1/2 would have to go out there. You can see how they connect. When the inside is linear, you don't really need u sub. Do I put plus c? No. because it's definite. Now here's why I wanted to use an exponential. When one of the limits is 0, people just kind of blanket go, yay, but what do you have to be careful about here? What is e to the 0? What's e to the 0? 1. Okay, so you can't just leave it out. When you put a 3 in, you get 1/2 e to the 6. When you put a 0 in, you get 1/2 times 1. Maybe. Okay. Now let's do another one. I'm going to do this one two different ways. I'll do the textbook way first, and then I'll show you my freaky ass way. You can pick whichever one you want, I don't care. I'm not going to give you extra points if you use my weird ass way. Why do I know u sub will work here? What's the inside function? What would the inside function be? What is inside something else? 2x squared is inside an e to the something function, right? And what's the derivative of 2x squared? Something x. Is that in there? Yeah. See how you don't give a shit about the constant to see if u sub will work. Is the functional piece of the inside function, is the functional piece of the derivative of the inside function in there? Yes. X squared's there, x is there, I'm good. So what do you let u equal? 2x squared. I love it. If you let u equal something and the derivative is not in there, you have picked the wrong thing, or it's not going to work that way, or something. So what's du? 4x dx. I love it. Do I see 4x dx in there? I want to put a 4 here, so I better put a 1/4 there. Now, what do these limits relate to? 0 to 3 for what? What's going from 0 to 3? X, right? X is going from 0 to 3. What am I about to do? I'm about to change all the x stuff to u stuff, right? That's the whole idea of u stuff. I'm trying to change all the x stuff to u stuff. So the limits have to pertain to what the variable inside is doing. Is u doing the same exact thing as x is? The only way that would happen is if u equaled x. Does u equal x? No. What does u equal? 2x squared. So if x is 3, u is what? What does u be? I love my grammar with u sub. U is what? If x is 3, u is? What's 3 squared? 9 times 2? 18. Okay, come on. If x is 3, u is twice 3 squared. If x is 0, where the shit am I getting 3 from, by the way? Yeah, right there. If x is 0, what's u? U is 0. I like it. So how do I rewrite this integral then? It's going to be the integral. So let's see, we got 1/4. Integral from 0 to 18. Be real careful. Sometimes it's possible that 3 will become something smaller than what 0 becomes. 3 went to 18, 0 went to 0. I put them in the same place. That is really important. What's the inside? What's 4x dx? What is that? What's 4x dx? du. And what's e to the 2x squared? E to the u. So u sub focuses your attention on the form of the problem. So it takes all the extraneous shit. What's the 4x actually? It is the derivative of that. It's the chain rule piece. So then what's chain rule about? It's something e to the function, right? This is the derivative of that function. So see how this kind of captures it. There's u and there's du. the derivative of that function is there. It makes it much more focused on the form. So what do you get? 1/4. What's the integral of e to the u? E to the u. And what was u? Oh, I'm sorry. I forgot which way I'm doing. I replaced everything with u stuff, right? Because I don't do it this way, to be honest. But I think this way is better for most students. But I'm still going to show you my way. Why is it okay to leave the u there? Why don't you bring it back to what x was? Because I changed the limits. What are the limits all about? U. Don't bring the x shit back in and then plug 18 into that shit. Does x get up to 18? No. What gets up to 18? U. Then you die. It's Logan's Run. Well, that was 30, but oh well. So if you do the method where you change the limits, you don't have to take u back to x. One reason I hate this method is because if the limits aren't there, you have to take it back to x. And your brain is like, when do I take this shit back to x? But now I got to do, what was this? It'll be 1/4 e to the 18 minus 1/4. Because e to the 0 is 1. I like it. So let me show you the way I would do this problem, and you can pick which way you like. Don't mix them though. It's never good. If you did my method for another teacher, they might look at you funny. But the way I look at it is, once you're past calculus, you are got to make math your own thing. If the teacher's inflexible, you do it their way, but you go, dude, what the shit? All this shit's made up. Right? It really is. It's not completely made up. It models things. It's useful. But you should be able to develop your own way of doing things, and if it's a good teacher, they should be cool with it. If they don't understand what you're doing, you don't understand after you explain it to them, something's wrong with them. Or something's wrong with your way. One of those two. So the way I would do this, where'd it go? It started off as this. I would do u sub. I would do that. So that step stays the same. I still got to bring a 1/4 in. So I would get to right here. I would leave. Now watch. This is why I don't blame you if you don't want to do this. So far it looks exactly the same as over there, right? What I do, as a student, I hated that I had to remember when to go to u and whatever. I always took it back to x. So what I do right here, I don't want to do this stupid step then. What I do right here is I would put in parentheses to remind myself, those aren't for u, those are for x. Those aren't for you. Is everybody cool with the fact 0 to 3, what goes from 0 to 3? X goes from 0 to 3. So one option when you take it to u is to change it to say, what does u do? I love my grammar. What does u do? So u goes from 0 to 18. So you don't have to bring it back to x then. You can just plug that shit straight in. Well, what I always like to do is to keep the x stuff. Do the integral of the u stuff. Okay, that's going to be 1/4 e to the u. And bring back the x stuff. And to plug that in, I'm going to get the same shit, of course. It's the same math, just organized differently. Neither one is a shortcut. They both take about the same amount of time because they both do the same math. They just do it in different places. This is what math is. Do you understand the idea well enough to handle different ways of doing it, or even to come up with your own way of doing it? That's the difference between add 2 here and why do I add 2? Is there a better way to do this thing? You're not freaking math soldiers. You get to actually question why the shit you're told to do something. So is it cool that I get the same exact answer here, right? Yes, of course I do. All right, so let me give you this. I got a little handout. Got u sub sort of splayed out for you. I want you to try these problems on this paper. So I give you an example.